Hello and welcome to Module 7. This module is all about the gears. We're going to take a look at some of the theoretical or the introductory concepts on the gears and then try to mesh these gears using the SOLIDWORKS. So what are the gear classifications? They can be divided into these three categories. One is the parallel axis gears, intersecting axis gears, and the non-parallel and non-intersecting gears. There are several examples in each of these three different categories. Spur gear, which is the most popular and commonly used gear, is in the parallel axis gears. These categories are based on the power transmission. So for example, if you want to transmit the power between the two shafts which are parallel to each other, then any of these gears can be used for that particular application. Same thing with the intersecting axis gears. So if the power needs to be transmitted across the two shafts which are not parallel to each other, then either the bevel gears or the meter gears can be used to meet that criteria. And then also if the shafts are non-parallel and non-intersecting, then either the screw gear or the worm gear or the hypoid gear can be used. These are just a few examples of different types of gears, and there are so many other kinds of gears which are not listed in this list of the classifications that can also be used in an industry. So let's begin with the parallel axis gears category, and let's take a look at some of the examples in this category. So starting off with the spur gears, so these are the gears which has the cylindrical pitch surfaces, and they're also called as the cylindrical gears. The spur gears belong to the parallel shaft group, as we just looked at in the previous slide, and these are the cylindrical gears with a tooth line that is straight and parallel to the shaft. Okay, so the spur gears are most widely used gears, and they can achieve very high accuracy with relatively easy production processes, and that's also a key factor in using these spur gears. They have the characteristic of having no load in the axial direction or the thrust load. Okay, and also when we look at the meshing of the spur gear, then the larger of the meshing is called as a gear, and the smaller one is typically called as a pinion. So that is the spur gears, and we will take a look at the example on the spur gear in the next part of this module. The internal gears have teeth cut on the inside of the cylinder or cones, and are paired with the external gears like this. So the main use of internal gears is for the planetary gear drives and the gear type shaft couplings. There are limitations, however, in the number of teeth differences between the internal and the external gears because of the involute interference. Involute is the profile which represents the tooth of the gear. The rotational directions of the internal and the external gears in the mesh are same, and they are opposite when the two external gears are connected together. The rack and the pinion is also another category of the parallel axis gears, and these are the same sized and shaped teeth cut at equal distances along the flat surface or the straight rod, and this is called as a gear rack. And a the pinion is the one that is meshing with this rack. So basically what it is doing is that it is converting a rotational motion into the translational or the linear motions. These gear racks can be divided into straight tooth racks and also the helical tooth racks, but both have the straight tooth lines. By machining the ends of the gear racks, it's possible to connect these gear racks end to end as well. And the helical gears are the ones which are used with parallel shafts, similar to the spur gears, and they also have the cylindrical gears with winding tooth lines. They have a better teeth meshing than the spur gears, and they have a superior quietness, and they can transmit higher loads as compared to the spur gears, and that makes them suitable for a very high speed application. When you use the helical gears, they create the thrust force in the axial directions, unlike the spur gears, and therefore the thrust bearings are absolutely necessary when the helical gears are employed in the practical applications. Helical gears come with the right hand and the left hand twist as well. That requires the opposite hand gears for the meshing pair. Now let's come to the category of the intersecting axis gears. Bevel gears are the cone-shaped appearance gears, and that are used to transmit the force between the two shafts, and that intersects at a point. So if you look at the axial direction of one of the meshing gears and the other gear's axial direction, they will intersect at a point. And so therefore this category is called as the intersecting axis gears. The bevel gear has a cone, as its pitch surface and its teeth are cut along the cone, as you can see from these figures. And there are different types of bevel gears that includes the straight bevel gears or the helical bevel gears, the spiral bevel gears, and also the meter gears. So meter gears are basically the same as the bevel gears, only the difference in that being the ratio is 1:1 for the meter gears, which means that there could be either speed reduction or speed increase in the case of bevel gears because of the different tooth sizes. But in case of the meter gear, both the gears meshing pair have equal number of teeth. So whatever the velocity of the driving shaft's gear is identical to the driven shaft's gear. The spiral bevel gears are superior to the straight bevel gears because of the fact that there is a high contact of the meshing teeth from both these gears, and that basically reduces the vibrations and noise, and also adds on to the strength as well as the higher efficiency. But at the same time, they are more difficult to produce, and also because of the teeth are curved, they also cause the thrust forces in the axial direction. Within the spiral bevel gears, the one with the zero twisting angle is also called as a zero bevel gears. Okay, so if the spiral angle is equal to 0, then that category of gears is called as a zero gear, which also falls into this intersecting axis gears category. The third category is the non-intersecting and the non-parallel axis gears. As you can see from these figures, that the gears which are meshing with each other are having their axes which are either non-intersecting or non-parallel to each other. There are again different types of gears in this category: the worm gear or the high point gear or the screw gear also. In the worm gear, a screw shaped cut on the shaft is called as the worm, and its mating gear is the worm wheel, and the pair together is called as the worm gear. And they have this characteristic of the non-intersecting shafts. The worms and the worm wheels are not limited to the cylindrical shapes, as you can see in this particular figure, but they also have the different types of profiles as well. But then the production becomes more difficult, obviously, and also due to the sliding contact of the gear surfaces, it's very important to reduce the friction. And so for this reason, a hard material is typically used for the worm, and the soft material is used for the worm wheel. Even though the efficiency is very low due to the sliding contact, the rotation is typically smooth and quiet. And that's one of the advantages for this worm gear to be used in the application. Also, when the lead angle of the worm is small, it creates the self-locking feature as well. For those who will be in the mechanical engineering field, would obviously learn quite a bit about the gears in much more details when the course on the machine design is undertaken. Now let's take a look at the spur gear nomenclature. There are several important terminologies that you have to remember or keep in mind while designing the spur gears for a application. Let's take a look at the tooth profile here, and there are several terms here. Let's go over them one by one. The most important circle for that gear is called as the pitch circle, and the term associated with that is the pitch circle diameter. So this is the diameter that is used to define the spacing between the two gears. So if you want to have two gears meshed with each other and to have a perfect smooth power transmission, then their pitch circles needs to be tangent to each other, and that's the most important criteria for a perfect meshing between the two gears. So the pitch circle diameter is not exactly at the halfway between the topmost part of the tooth and the lowermost part of the tooth, but it's slightly on the upper side. So there is a little bit of an offset, as you can see, which is defined by the term addendum, that is the distance between the pitch circle diameter and the outermost circle for that particular gear. So that distance is addendum, and the dedendum is 1.2 times more than the addendum distance. Okay, in this case, m represents the module of the gear. The module is a term that is used in the metric sense. For the inches system of units, the gears are typically referred by how much is the diametral pitch for that particular gear. So in an identical way to the screw threads, as we looked at in the previous module, the metric system of units and the inches system of units work in exactly opposite way. For example, in this case, the diametral pitch P is given as the number of teeth per inch. Okay, exactly in the way as how we define in the inches system of units for the threads, where we say that the pitch of the thread is equal to number of threads per inch, and in this case the pitch of the gear is equal to number of teeth per inch. And in the metric system of units, in the case of screws, we define that as the distance per thread. So in this case, the module m, which is equivalent to the diametral pitch of the inches, is referred as the distance per tooth, and that is basically the module in the metric system of units, which is equivalent to the pitch of the inches system of units. So the meshing gears obviously must have the same diametral pitch, and that way the pitch circle diameters would be tangent to each other if we make sure that their diametral pitch are identical of the two meshing gears, which means the number of teeth per inch, that criteria needs to be satisfied to be equal for the two meshing gears. So if one gear has let us say 20 number of teeth, and let us say that it has the diameter of the of that gear is equal to 1 inch, just let's say these numbers. So its diametral pitch will be equal to 20 divided by 1, which is equal to 20. So the diametral pitch for that gear will be equal to 20. But let's say we want to mesh this gear with the other gear. In that case, let us say we have the 40 number of teeth. So let's say first gear is like this, and it has 20 number of teeth, and let's say we have the other gear which is bigger than that and it has 40 number of teeth. Okay, so the first gear has 20 teeth and the second gear has 40 teeth, but in order to have a smooth meshing, we need to have their diametral pitch constant, which means the consecutive distance between the two teeth needs to be identical, just like in the case of the screws. So if the pitch circle diameter is 1 inch here, which means the diametral pitch will be equal to 20 over 1, which is equal to 20 over 1, which means the pitch circle diameter for this other gear should be 2 inches. So that for 40 teeth, again the diametral pitch will be same. There are other terms also in this gear nomenclature. The topland, which is the topmost flat face of the gear tooth. The gear profile is typically an involute profile, and on the side of this tooth we have these two terms, the face of the gear and the flank of the gear. The line that is drawn which divides the face and the flank has to be along with the pitch circle of that particular gear. Okay, the circular pitch is the distance in the circular fashion from the same point on the first teeth to the same point on the next teeth. Also, the face width is important when we define when we design the gear. And the other important term is the pressure angle. So when the teeth are in contact to with one another, these teeth basically make a single point contact, and if we draw a horizontal line in the front view of these gears, then a normal drawn to that particular point of contact will make an angle with this horizontal line. So this is the line which is making a normal to the point of contact on the two teeth, and then the pressure angle is the term that defines how much is the pressure that has been created by the first gear's tooth on to the next gear's tooth. The gears are manufactured with the standard pressure angles, either 14.5 or 20 degrees. And also, in order to have a meshing, perfect meshing between the two gears, the center distance is also important. And once we know what is the pitch circle diameters for both these gears, let's say D1 is the pitch circle diameter for the first gear, D2 is the pitch circle diameter for the second gears. Obviously, in order to have the perfect mesh, we need to have the diametral pitch P, and P1 and P2 should be identical, and N1 and N2 are, let us say, the number of teeth. So I'm gonna cross out this 1 and 2 because the diametral pitch should be the same. So P should be equal to P, and based on the equation that P equals to N over D, so diametral pitch equal to number of teeth divided by the pitch circle diameter. So N1 and D1, and P equals to N2 over D2. But if both the pitch needs to be identical for these gears, then N1 over D1 should be equal to N2 over D2. And so that way, if the first gear has 20 teeth and its diameter is 1 inch, And if the second gear has 40 teeth, then its diameter should be equal to 2 inches to make the ratio of N1 over D1 same as N2 over D2. Okay. And again, the module is the pitch diameter divided by the number of teeth, which is opposite as in inches system of units, where we use the term diametral pitch instead of module. And the diametral pitch is defined as the number of teeth divided by the pitch diameter. And just to conclude this brief introduction to the gears, there are few websites. Obviously there are a number of websites that can give you a lot of information on the gears and their CAD files. But again, the macmaster.com, the rushgears.com and the khkgears.net have plenty of good information on creating this gears. So for example, if I go to the macmaster.coms and type in gears, you can see there are various categories of gears provided here that you can simply choose the parameters that we want, say shaft diameter or the pitch diameter, how much we want the pitch and the number of teeth as well, what kind of bore type also we want, and all these informations once we put it, including what kind of gear type that we want, then we can generate these gears. Let me just go over one of the examples here. For example, I want to use this one of these gears here. Simply click on the file, go to the product detail. It tells you what is the outer diameter is reference to, what is the pitch diameter that needs to be matched with the other gear's pitch diameter, and also there is a hub width and there is a face width for the gear that we can input to design that particular gear. We can of course save that part, and once I click and open it in, let us say, the SOLIDWORKS, then we can generate that gear and save it as a part and then use it in the design. So the face width is the distance from the front face of the gears to the back face of the gear. The hub is the extended portion for the gear from the back face of the gear to the end face of that extruded cylindrical portion, which obviously has a hole to enable the insertion of the shaft into it. There is a hole here that will be used for the set screws, or you can also design the gear that has a keyway here so that the key can be inserted to lock the motion between the shaft and the gear. So that one way of creating the gears from the macmaster.com. Or in the SOLIDWORKS also, we can go to the design library, click on the toolbox, add in now. Let's say we go to the inch system of units, power transmission, gears, and then you have all these different types of gears that you can create. For example, right click Spur Gear, create part. Then once we input all these parameters as we want, for example, diametral pitch, let's say I set it to 24, pressure angle 20, face width, let's say 0.5. Let's say hub style, we want it on both sides, so that way you can see the hub created on the both sides. Or if we just want it on one side, then it will be just created on one side. Hub diameter also we can input. Overall length also we can input for this gear. Nominal shaft diameter, if we need a keyway or not, that's another option. We can have either a square or the rectangular key, so that way you can see a key generated. And then once we click on the check mark, the gear will be created with the specifications as we set it up for the designing of that gear. Other way to create the gears is if you visit the website rushgears.com. If you go to design tools, click on 3D CAD. There is a window which you can input the values that you want to create to generate the gears, or you can simply click on the CAD to generate that particular gears, SolidWorks or any other 3D CAD modeling file. Or you can first set up the properties here and narrow down your choices. So for example, if I say pitch 24, teeth let's say 20, so I get down to these 3 different choices that I have. The pressure angle, let's say 20, then I have these 2 choices here. Style is either A or B. Both are available in the B style. So the style, A style is without a hub, B style is on one side of the gear, and the C style is on the both sides. So once I click on the CAD, then for 3D model I can use whichever the software that I want to set up, the version for that, and once I click on get 3D file, it will generate the SolidWorks file, and then I can again save that as the gear. So there are different ways of creating the SolidWorks files for the gears. And again, the other website is KHK Gears. So that is also a pretty good website that you can learn how to create the gears on that website as well. So I hope this is informative to get started with the gears, and in the next episodes of the module we will go over the SolidWorks part of meshing some of these gears. Thanks for watching. I will see you in the next one.